All yours, Will.
Camera spooling. All right, so I guess first of all, I just want to talk a little bit about, before I even get into who I am or what I'm here, so where this talk came from. So Nimrit and I were batting back and forth ideas for a topic. We came up with this idea, CSI, CL Java, and the pitch for it was, let's have all these really like horrible, nasty bugs, and then we'll all work together as a group to kind of figure them out. And the only challenge on that was, especially as I was going through it and generating a bunch of bugs, trying to debug somebody else's code is actually kind of a pain in the arse. So I think I'm going to show a little bit more behind the scenes, so that way you guys know what's going on with it. But the idea was to look at, the JVM blowing up, and how do you figure out what's going on and what's happening with it. So that's the idea behind the topic. So my name's Will Iverson, and who am I? I've been doing Java since 1995. I was actually working on the pre-1.0 JDK at Symantec. I spent time at Apple working on the JVM there. I've done consulting with Sun, BEA, written 4 books on Java. And today, my day job is I'm the architect at All Star Directories. They just finished a huge porting project to go convert their entire business over from PHP to Java. And then in addition to that, in the evenings, on my side time, I also have Nukia, which is a training consulting company. So if you look in the back, there's some flyers on a class I've got coming up on Agile testing. I'll talk about that a little bit more at the end. So the premise with CSI, CL Java, IT has dead bodies. So what's a dead body look like in the Java world? Look at that, and then what are we going to do about it? So the first question is, I'm guessing all of you work in an environment, or most of you, where you have your dev boxes, and then you're also working with an IT group that gives you back stuff from production. Is that fair to say? So how do you hear about problems when they're showing up? Anybody? How do you hear about this?
The email box.
What's that?
We intercept anything that happens and we get emails from it.
So you get emails from the bot, from IT with the issues.
From any machine that's deployed on that.
From any machine that's blowing up. So what's included in those emails?
Stack traces.
Stack traces.
And any session information, request information, anything that we can gather.
Okay. So you get so it's usually associated with a specific page request.
Right.
Okay. So this page, when I hit it with this URL with these parameters, it goes.
Right.
And
So
then you get a stack
memory
trace.
error wouldn't be.
So you don't get a
wouldn't be
memory
a
errors.
problem.
Okay.
Yeah, but it wouldn't be clear from the information that we get. Right.
Right. How about like any other kind of like a deadlock thread? How would you ever find out about that? What did any of you ever find out?
-3 to get the done.
What's that?
You do kill -3 on the Java process to get it done.
So you get a thread dump from that?
Yeah.
Okay. So basically, how many of you, does anybody here have the ability to hook a profiler up to their production environment? You're nodding your head. Where do you work?
Well, QA mostly.
Okay, QA environment, not production.
We can do it in production, but you just don't tell anyone.
It's on tape, you're in
I guess
trouble.
we're not, a huge corporation yet, so.
Right. So once you get past a certain stage,
Yeah.
you stop being able to hook a profiler into production, right? So then what are the next best things? Heap dumps, right? So what is a heap dump? I'm assuming if you don't know what a heap dump is basically taking all the memory from the JVM and dumping it out onto disk. So they can get to be fairly large files, right? So there's a couple of different ways that you get heap dumps. We'll talk about that. And then thread dumps, right? So what's the difference between a thread dump and a stack trace? Basically, a thread dump is all of the stacks for all the threads that are running, right? So it's a nice way to see what's going on. It's a really good way to find out things like deadlocks, for example. So how do you get a heap dump? You have an out-of-memory error, right? So if it's an exception on a page that you get, that's going to be fairly easy to straightforward to fix, right? So everybody's favorite's a null pointer error, right? What happened there? I forgot to put something in the object, so now it blew up. It's pretty easy to figure out what's going on. Or even more embarrassingly, the JSP didn't compile it or something. Okay, we're not gonna talk about that stuff. That's a little too straightforward. Heap dumps, something blew up without a memory. What's going on? So how do you get those? Well, one of them, and this is actually one that you might be able to convince your IT guys to flip on in production, is you can actually pass an argument to the JVM that says, generate a heap dump whenever there's an out-of-memory error. It's pretty nice. Then you can get, then they'll typically find them. They can zip it up for you, mail it to you, and then you can open it up in the tool. And we'll show examples of that in a few minutes. There's a command line tool called JMap that you can use. Run that, and it'll generate a heap dump. JMap doesn't work sometimes, though. For example, on Mac OS 10.6.2, it doesn't work, and if you try and run it, it just says, sorry, not supported. Another tool you could use is JConsole. So that allows you to go in and fire up a JVM and instrument the other VM, and then say I want to go ahead and do a heap dump. And also JVisualVM.
So, just out of curiosity, it seems to me like you're talking about Java production applications that are being run by starting some type of service. Are you going to talk about anything that uses containers such as WebLogic, JVMs, or
Yeah.
JBoss?
So all of these will work just fine. So, and just to figure out for demo purposes here, who's used JVisualVM? 2 hands. Okay, where do you think JVisualVM comes from? Anybody want to guess? People who don't? It's actually bundled with the JDK. So since only 2 people raised their hand, I'm going to take a moment here to go ahead and bag out and do some demos real quick so that way people know what I'm talking about. Okay. Now, so you mentioned containers, right? Services running. So what's everybody's favorite container nowadays? JBoss, Tomcat, Jetty. So JBoss doesn't actually do its own web container, right? They're either web retro, man.
Sorry.
That's man with too much money. No.
Damn straight. I wish they just give it to me.
And that's coming from somebody who used to work for did work for BDA. Okay, so let's go ahead. I actually have everybody's favorite Tomcat running underneath the covers right now. So I just fired that up. Actually a good segue. So I've got my couple of apps running. This should all look very familiar. I do have one little demo app that I'm going to be talking about more in a minute. Okay. This will work or not? Yeah, okay. So you almost certainly can't see that. Okay. All right, let's try the most basic one. So this is just bundled with the JDK. So I hit run. Voila! This whole management console is right here. Now, okay, well, I'm going to use JConsole to inspect itself. I had JConsole working on it. I'm talking to Tomcat. Yeah, okay, this is okay, so this is JConsole. It's bundled with the JDK. Everybody has access to it. Everybody can use it. And it's a pretty nice little administrative tool. And you can see from the connection wizard that if you have rights, you can connect to a remote one. So what's this thing showing me? Is how much memory I'm using over here, how many threads are going, what's going on with the CPU, and how many classes are loaded. So the only one that's kind of amusing about this is that just to bootstrap the JVM itself, basically you're talking about over 3,000 classes. Okay, kind of interesting. Here's your memory usage. A couple things that are interesting on here. Let's see, it's showing you some information about garbage collection down there. So you'll note that it's just kind of zigzagging along. doing its allocations. Now, anybody feel confident enough they could recite off all the different kinds of memory in use by the JVM? You do? You think you can? Okay, go for it.
So we have hidden space, we have permanent space, we have classes or all generic memory space, and we have two survivor spaces.
And two survivor. Okay.
Yes, and also what's not reflected by Java is the system one, native from Java. JDK. Here are stored system information objects like threads, file, handles, and so on.
Yeah. So those you have to
And
get.
this is not included in Java parameter size.
Right. So for that, what you have to go to the operating system
Yes.
tools to find that information. So you have kind of two worlds that you're living in: the Java version and the native world. So in the name of prizes, I brought some candy bars. So, no, don't trip. So CMS old, Eden, Survivor, Code, permgen. Does that sound about right? Gave it kids credit. All right, so you earned your pay.
I don't.
Wow, I didn't like kill you with that, right?
It's
Okay.
very difficult for.
That's oh, go, you can give it to somebody if you want, whatever. So, what's non-heap?
Applications.
Stack. Okay, so what's going on here with these different kinds of memory? Why do you need all these? And just to make why this is a little bit of a trick question is every JVM has actually updated its memory model for what's going on. So the categories that you'd see in something like this tool are going to be different between different versions of the JDK. So heap though is usually where you're going to have problems. What happens if you have a problem on the stack with memory? What's that going to look like? Stack overflow. That's usually because you're looping down too low.
Yes. And this is a parameter based on system.
Okay.
I have a question. Yeah, the non-heap, is that the native memory as well?
Non-heap, is that native memory? I don't believe so.
So this doesn't report like direct click buffers, things like that, all the allocations associated with them.
Usually it happens, in this case, JVM completely dies. You have a different kind of repo.
Right. And that's actually a great segue into the baseline for what's going on, right? So I can hit threads, I can see what's going on with the threading, see how many classes are loaded, see the JVM. One of the things that's really useful here, maybe your class path, figure out problems with that. And then, of course, mbeans. So what the heck is an mbean? These are all the JMX entries. So this lets you see things into what's going on that you may or may not normally have access to or want to see. So this is a pretty raw way to be able to get into operations like I want to do garbage collection remotely. So this is all the management instrumentation stuff. Okay. So this is one tool. And part of what we were going to talk about was doing a heap dump. So one of the ways that you can do this, one of these in here lets you actually go in and generate a heap dump. And it's a very, very painful way to do it. What's that?
Go down to
So, okay, here's an example. One of these in here does let you do it for heap dumps. But what you would do is you would actually pass in the parameters here, and because it doesn't have any info, you'd have to go look up in the Java doc for this to figure out what the options were, and it's going to be like, what's the path that you want to drop this to. So this is a very painful way of getting in and doing it. But you can get things like thread dumps, heap dumps, and things like that way. So this is another tool. This is one that if you're like on some of the mailing lists for things, you'll actually see this show up. It's interesting. So my Tomcat's not showing up, so it's probably because
This is one of the problem. Don't look at it because if the process was started natively by using module stuff or as from Windows, DLL stuff, it will not show on SeaJUG.
yeah. So I think I booted Tomcat.
Just
with the wrong
run
version.
a different application, Java application. You will see.
So this is another way of getting in and seeing similar data in a much nicer, richer format. And one of those over there, one of the buttons that you can hit is heap dump. So I can go ahead and say, okay, let's go ahead and yank a file showing what's going on with the memory. So it can take a little while to generate a heap dump. And here you can see some of the summary information. So this is what's going on now. Not surprisingly, there's a lot of strings. And I can go over here and I can actually save this file. So let's go ahead and just put this on the desktop here. And I can inspect this further. Now, so that's a dead body, right? Effectively, it can be, right? Now let's look at another one. Let's do the thread dump.
I will.
Yeah.
Can you load up a heap dump into this?
Yes.
That's what we're going to be doing next. Because this is where we're actually getting to the interesting part. So when I talked to the IT department at ASD about a year ago, when I first came on, and I said they were reporting out of memory problems on the server. So I said, okay, give me a heap dump. And they looked at me like, you want a what? You know, it sounded like I wanted to do something bad to their offices or something. You want to dump what? And so I basically had to walk them through this, right? It's like, how do you get information from your IT department about a server that's blowing up in production without memory problems? So heap dumps are the way to do that. So absolutely, you have to do this. Now, one of the challenges, of course, with heap dumps is that they can get to be very large, right? So I'll talk about that a little bit more later. You know, if your production machine has 4 gigabytes of memory allocated to the JVM, you're going to get a 4 gigabyte binary file on disk, if not bigger. So maybe by about 10 to 20%. So then that means that you have a large file that you need to spool off, just like we just did on that. And then you have to get it over, and then you have to open it up in the tool, and then the tool's going to want typically 3 to 4 times the memory of the file. So this is a great, as I have a slide of this later, this is a great excuse to get like your 64-bit, 16 gig NAND machine if you're going to be looking at big heap files from production. Okay, so here's my thread dump. Here's my live threads. Now I can hit thread dump. Now thread dumps are going to be a lot quicker than heap dumps. But this is a great kind of like way to kind of get to know the neighborhood for what's going on, right? So this is all the different threads that we're running on the JVM just sitting there. Request processors, event queues, right? So this is everything that's going on. Now, what's interesting is this is the stuff that you kind of get for free, right? So I've just booted up a JVM. I load over 3,000 classes, and I've got a whole bunch of threads running.
Is there a cost for the monitoring, or is that because it's already built in? Is it actually free? Is it free for the monitoring, the profiling?
Uh-huh.
Is it free to you because it's already instrumented on the JVM to start with? Or is there a cost? Is the tool interrogating the JVM, or is it just reading data that's already exposed?
Yeah, so the question is there a cost to getting this data?
Yeah.
And my observation is that yes, there's a cost because it has to, walk through the data structures, generate it. So like, just generating a stack trace is actually kind of expensive, depending on your point of view. So you're going to be generating a thread or a stack dump per thread at the very minimum for a thread dump. So it's not trivial, and how long it takes depends. So one of the little samples I have is, let's generate 10,000 or 100,000 threads, and then do this and see what happens. And so if you're doing something like that where you've got a lot of stuff going on, it can actually take a while. Heap dumps, there's just no way to take 2 gig of memory, 2 gig of data, for example. Let's say you have 2 gig of memory allocated to your server. There's just no way to take 2 gig, write it to the disk, and have that be instantaneous. And it's got to pause while it does that.
Yeah, that's the key. I mean, it doesn't really matter that it's slow, right? It just depends on what the impact on the monitored process is. It doesn't matter if it takes it 10 minutes to do the
Yeah,
operation.
I believe it
But
pauses.
if it locks the JVM whilst it's doing it, then that's not going to work for you on a live system, right? It's like,
Yeah.
okay.
Well, and that's where like the heap dump on out of memory
Sure.
is a good way to go because on production, because then it's like it's going to die. Now just so you know, the VM itself can be put in a state where a heap dump on out of memory will not work or will generate corrupt heap files. So depending on how badly you're hosing things. Now what I would recommend in a scenario like that is to, I'll talk about how to cope with some of this stuff, but that's why you need a perf environment that you can load up to recreate the conditions whatever you need to do.
One caveat about the heap dump on out of memory is that it'll generate a new file every time.
Yes.
So you have to make sure that if you're doing that, you have something that's monitoring and cleaning up,
Yeah.
or you're going to end up filling up your disk, telling you that you're out of memory.
Yep.
Actually,
And some.
you can dictate to where to store this file.
You dictate a directory, and it
Yes.
generates a new file every
Yes,
time.
yes. So
It helps,
this is
but you
one
still have to
basic-
make sure, you have to remember to clean up.
Yeah.
Yes.
Yeah, you definitely want to clean it up. And some of the servers are better than others. Like from what I've seen, like JBoss has got this like monitoring thing where you can tell it just do it the first time that you hit that page with that problem, and then it won't do it after that. Okay. Oh, and JMap, JVM flag. Oh, okay. So these are the tools. What I just showed you were some of the tools that were built into the JDK. All of the profilers also have the ability to click a button and get a heap dump or get thread dumps or what have you, but that's kind of back to that problem that we were talking about before, which is, well, if I can connect to it with a profiler, right, that's not a dead body from IT, that's that I can do anything I want to at that point. It's usually only dev. Same thing with thread dumps, the JHAT analysis tool. Why did I go to thread dumps? That shouldn't be there. So, okay, just as a historical accuracy point. So here's a heap dump, right? This lets us do some simple analysis, and we're going to talk about those. The JDK itself bundles in a tool called JHAT for heap analysis, and you're not going to want to use that. Well,
This is not the tool you were looking for.
no. I'll show it to you guys because it's kind of funny. So this thing does the last thing you would ever expect a command line tool to do for doing analysis. It reads all these records. It reads all the objects in the heap dump, and then it actually fires up a web server.
Expect 41 dots.
Oh, yeah, and you guys can't see. It says chasing references expect 41 dots, and that writes out 41 dots.
It's like, can I count that fast? I don't know.
Okay, so this is what you get. So this is I'm browsing the little mini server that the local console app generated for me. So I can go in here and I can click and browse around and see what's going on. And it's a very strange tool that, and the craziest part about it is they actually have its own special, it actually has its own special query language that you can use to find things. So it's a very, very strange tool. So you could theoretically use this, but I don't know why anyone would. If you can use these other free tools, or you can, all of the profiling tools I'm going to show today are all like a couple $100 at the most. So just don't go there. Don't bother with JVM. So the thread dumps, there's actually a command line tool you can run, JStack, where you just attach to it with the process identifier. JConsole and JVisualVM, you saw both of those. So here you guys, here we go. It's just for grins here. Let's go quit. Okay. So I don't know if you guys knew this or not, you can actually use a JPS command to just see the Java processes. So this is how I can just interactively get a thread dump from a currently running JVM through a command line. It's kind of a weird, just by asking it by its process. So you could, of course, just pipe this to a file or something like that. This would be like if I'm just logging into a remote server, I have no other way of getting access to this information. I could do this command on anything that has the JDK. Okay.
So, well, I got a question.
Yeah.
All right, so when's the best time to use something like that? You're dealing with a problem, you know, it's not sitting there waiting for you, typically, is it? For you to come in and just do a JStack thread dump to see what the problem is and go from there. In your experience, when are you actually going in and doing it in a JStack? What time?
So the question was, is when do you actually go in and do a JStack, right? Or for that matter, a thread dump or a heap dump or
Yeah, so that you know it's going to give you something that's useful.
yeah. So yeah, the two times that or 2 or 3, I guess. Well, I'll just rattle. Okay, so one of them is when nothing's going on, which is this slide right here. So it's really good to know what your container looks like, basically when it's just sitting there. Because a bunch of the tools actually let you do diffs, like heap dump diffs. So you can say, this is my reference heap dump, this is what the heap dump looks like when something happens later. So, and the profiles for these things are totally different. I mean, if you're running Tomcat or JBoss or WebLogic or whatever, when they're just sitting there chilling, not doing anything, they're going to give you very different profiles. Then where I use this stuff more nowadays is in the perf environment. So we'll put stuff under load, and if we see anything squirrely, usually from the system tool. So there's a tool on Linux called SAR. So when we do our perf stuff, we'll have SAR running, and it's sampling. It's saying, what's the world look like right now? And then what will happen is we'll get to a point where if we see anything interesting, then we'll say, okay, you know, we crossed a certain threshold, do a heap dump, do a thread dump, right? So like we're now putting in some scorecarding, because for a while we've been in sort of, at ASD, we've been in this sort of mode of like, you know, did it, you know, blow up the server and kill everyone in the room? No, okay, I guess we're, you know, and now we're getting into like, you know, more and more perf work. So what we've done is we've defined certain thresholds that we don't want to hit. Like, okay, well, when this application, if it hits more than a certain, you know, CPU load or what have you, then use that and then trigger taking a heap dump or thread dumps.
So it sounds like what you're saying is that the trick here is to use this in a regular way so that you understand when you start to see abnormalities, as
Right.
opposed to expecting to get much out of it if you just use it once and try to fathom what the
what that scenario looks like is, if you're just cruising along, you don't worry about it, don't think about it, and nobody's complaining and the systems are running, it's kind of like okay. What it usually will look like is you're going along, you're doing your stuff, and all of a sudden everything just blows up and goes to hell, and you're like, I have no idea what's going on, and I don't know why. Well, in that case, then you may need to call somebody, right? So that's where consultants who've been doing this stuff for a while can be very helpful for you to figure out what's going on. Because otherwise, I mean, it's too specialized, right? It's too hard. It's going to be too hard. And they're going to have to come in and learn your app to be able to even tell you anything useful. And that's part of why this is kind of a fun topic, right? Is, to maybe push out the boundary for where you need help. Maybe you can kind of teach a man to fish kind of a thing.
When we have load problems, it's typically the connection pools, like the database connection pools, that load first and then start throwing exceptions and stuff. But you want to have insight in the other thread to know what is holding up. So that's one occasion. It's typically too late. That's for us a sign like, oh, we should have done this earlier. But that's an example of where it actually helps to use these tools.
Yeah.
As I was saying, it's based on the problem. All these tools are helping you to identify the code.
Yeah,
That's
exactly.
it.
Find it.
So this is mostly it shows the technical part, memories, stack traces, who is running, but sometimes you are relying on the layers that you've built somewhere, like logging. So sometimes you can turn on logging, change logging properties even in production, and you obtain traces. So this is also helpful.
Yeah, for database we use a driver spike to get all.
Yes.
Driver spike.
There is a
It spikes the GPG driver and gives all information about conversations between Java application and database. Driver spike.
Driver spot.
Yeah, it's very easy to do.
Is that a free tool?
yes.
I'm sorry, what was the tool that you mentioned?
Driver spy.
JDBC driver spike.
Oh yeah, I use P6 Spy. Is that a new version of that or something? It's like a driver shim that instruments
Yes,
what's going
yes, yes. You are defining your driver and everything regulated.
on. Yep. Okay, so I just rebooted Tomcat real quick here, and now I was able to attach to it because I hooked to the right process. So this is Tomcat sitting idle, not doing anything. And of course, one of the most interesting things are the threads. Or this acceptor, for example, right? It's sitting there waiting for stuff to come in. Okay.
Well, there's also some mbeans built into Tomcat. It's also kind of nice as well, as far as it puts in connection pooling and things like that. So
Yeah.
if you have issues.
Actually, this is functionality feature of the frameworks that you are using. So if you are lucky and if you are using, for example, connection pooling from C3P0, yes, you will see. If we are using DBCO, Apache stuff, sorry.
Yeah. Yeah. Okay. All right. So, there's JConsole running. So let's go ahead and just for fun here. This is a little app called Crash Dummy that I wrote, and this is actually the source of some of the failures. And basically, what happened with this was IT asked me for an app that was just horrible. So I said, "You want me to write the worst app ever?" And they said, "Yes." So basically, I just started writing all these horrible things that I could think of. That's my horrible server thing to do, right? So let's go ahead and just try one of these and watch what happens with the console. So we saw the memory spike up a bit. Right? That was the first time that JSP had been hit, so compiled the page, stuff like that, about what you'd expect. Okay. So we kind of, how are we doing for time, actually? Okay. So we've got a chance to look at what's going on, and I've got 6 cases here of horrible things that could happen, and so we can kind of look at them and see what's going on. So I've got about, how long do we go typically till? 7?
What's that?
How long should we go till?
About 9.
Oh, really?
Yeah.
Okay. All right. Let's see.
Until we tell you
We
to stop.
can finish sooner. That's quite all right.
All right. I was like, wow. Okay.
We don't have to go all the way back,
All right.
but not too far past that.
Yeah. Okay. Let's not go quite that long. Let's see. Okay. All right. So what I'm gonna do now is I'm gonna open up a couple of heap dumps and threads, and let's kind of take a look at them and see what's in there and see if we can figure out what the problem is from that. Okay, so. Okay, so we've got one problem already. So IT has sent us a heap dump, and they've said, there's a problem with it, we don't know what's going on. Can you tell us anything else about it? So of these tools, what would we like to open the heap dump in first? Would we like, do you guys want to try JVisualVM and see what's in there? What would you guys, sure. Or do you want to try JHat with the web server? All right, we'll start with
Web server means hands down.
Okay. Let's see. So here's an interesting one. Compare memory snapshots. Actually, let's see. Let's start with the heap dump. Okay, so I guess the first question is, any idea what's going on from this? So what the IT guys said in this case was that the memory's getting consumed and not getting released as the server's running. Any ideas?
Parsing XML.
Parsing XML. See a lot of XML string buffer characters in there.
When you do a substring, you actually have a reference into the original instance. It never gets freed if you have any reference to it.
Yep. Okay. So, I don't know about you guys, but this is actually looking pretty hard. I don't think I'd be able to figure out what's going on from this, right?
Actually, either somebody holds references or somebody uses for parsing XML, JVM, DOM stuff. So everything is loaded in memory.
Yeah, it could be.
It depends on the problem.
Yeah. All right, I'm going to try another tool. Let's try something else. So here's a tool. This is called YourKit. This is actually a commercial tool, but it's not horrendously expensive. I think it's less than $1,000. I think it's like $250 if you're an individual user, or like 500 or 650 or something if you're a corporate, something like that. It's not too bad. Just go ahead and try opening up the heap dump. Okay, for starters, did you just see that little zip as it opened up? So this is actually a little tiny heap dump from a little local instance of Tomcat. That's the thing. That's the one that's going to kill you if you try to do this with like a 2 gig file. So, but we can look at this tool here, and this is starting to give me some more interesting information. Now I'm going to click on this retain sized. This is interesting. It's giving me slightly different information from the other tool. And that's interesting. Class showing up as really big with a lot of instances. Any ideas? Any guesses? Class loader? Okay, now we're getting closer. We're getting very close.
Probably communication stream doing deserialization.
Communication stream doing deserialization. Okay. Anybody else? Redeploying to the container. Excellent guess. Excellent guess. But IT does restart it. Very good guess. So on this one, and this is what I mean about how this gets really brutal unless you know the app that you're working on. So what can you do on a JVM that might generate classes? That's a hint. CG lib stuff. Now we're getting closer. Anybody else? Huh? JSP. Also getting closer. You're on the. So what is a JSP?
It's a servlet.
It's a servlet. And what would you describe the kind of programming that you're doing if you're writing JSPs?
Code generation.
Code generation. I'll give you another hint. Scripting. Right. So what other things might one be doing with scripting languages? Anybody?
Writing Groovy code.
Writing Groovy. There you go. So what you can have happen is you can have permgen space issues, right? So this is a brutal one because you would have actually seen this instantly if you'd hooked up JConsole. Because you would have seen all those classes getting allocated. Because here, in this particular case, it was actually, to be fair, this was actually a case where it was using a code generator to generate classes on the fly and then hanging on to them. Little interesting thing. Would this dump that resulted in this kill the JVM? Do you have to restart the server to fix it? There's actually 2 answers, depending on which version of Java you're running on.
Yes. No.
So if you're running on 1.5, then yeah, it could hang on to all the class references. But 1.6, at least on 1.6, whatever the current, whatever patch level I'm on here, I could double check. It's actually smart enough to clean up classes that have been loaded if the references were up, which is really cool. So what you might have walked away from here is saying, well, don't use something along the lines of, well, don't use Groovy because it's going to fill up your your permgen on you or something like that. And actually, if you're on 1.6, you're fine. You don't have to worry about it. It's no different than JSP or regular Java or anything like that from that perspective. All right, so I'm not quite sure who got the closest on that one. Ramsdale, you had some pretty good. You want candy bar?
I'm not Ramses.
I'm sorry, Belgard. Okay. All right, so there's our first dead body.
Well,
Yeah.
but again, what the difference was now between those 2 tools, what you did to get the better information there.
Well, so at the most basic level, this tool has a whole bunch of features in it, the other one doesn't. JVisual VM is this thing that's bundled that Sun gives you for free. And if I click back over into this, it's telling me the classes and the instances, right? And that's pretty much it.
So can you sort by size then?
Can, but this isn't as smart about stitching together the references.
So can you explain what the retained size is? Retained size when you sort it out?
Yeah, I believe that's paths from GC root. So if I click on this,
So that's the amount of memory that's being kept alive by instances of class.
right, so the shallow is just, if you took the objects and said this is what's going on, retained is this is what it's all hanging on to. So we're kind of jumping ahead a little bit, but this is actually one of the cool ones, is I can say, what the heck is actually hanging on to these things? Now in this case, it's a little bit, class is actually really hard, because it gets hung, the JVM itself can hang on to it. So that one's actually a pretty brutal one. But like, let's look at the hash maps here. So I can see what's actually hanging on to this stuff. So it's sort of, the joke is like, what the power of one little turn down to help figure out what the heck's going on. Okay. So I'm going to close that snapshot. And let's look at...
So, well, you're kind of proceeding as if you have any witnesses. You actually do. Most systems, you're going to have logs that are going to be isolated when something happens.
Yep.
And then at some point in time, you should be able to say, okay, I can try and recreate that in another environment.
Right.
Step through or go above something or whatever.
Right.
So there are, you're not suggesting we just use these tools. We actually have to use the whole realm of information available to us.
Right, and that's actually part of why it's CSI, right? Because the comment is that you shouldn't just work with this tool in isolation, right? Like you're not just going to take heap dumps and say, "Oh, I have heap dumps now. I'm never using stack traces again." It's like, no, that's not the point at all. It's these are additional tools that you can use to help diagnose and figure out what's going on, right? That's all this stuff is. So is it if so 3 people here had actually used JVisual VM. Right? I mean, that's a free tool that comes with the JDK. That's a basic one. Your kit is another tool for however much it is, $500. You can get a ton more information, but that doesn't mean that you're not going to be using log files and stack traces and all sorts of other stuff. And one of the key things, I think, I'll come back to this in the slides later, is all of this is totally dependent on the kind of software that you're writing, right? If I'm writing a basic web app, 99% of the time, any problems I have with performance or what have you, they're just going to be because the web app's talking to the database and doing something silly, right? So the only time, like you're going to, this kind of thing, if you're writing Tomcat, if you're actually writing multi-threaded code, you're going to be living in this stuff. So you always have to keep that in mind. It's just that we do live with these containers, right? So, yeah.
Actually, what I would like to mention is that Visual VM has a lot of plugins that can be plugged in, and they are very, very helpful. For example, Visual VM has garbage collection, visual garbage collection tool, which JConsole has kind of bitrace, for example, which is very, very useful. Tree dump analyzer.
Right.
They are, you can plug in even external ones.
Yep.
Is there actually a market or it's free? Is there a
Yeah,
site that has people who submit plugins to
Yes, they are free, open source.
All right. Let's see. Okay, let's try one more. Let's open up another one. Okay. So, Here's another one. This is kind of a little bit of a silly one, but it's kind of fun. So this one's actually been run. I believe I took this dump after having run the other one, so I hadn't cleared it out. So I created another problem. What leaps out at you guys as the problem looking at that? Ton of character arrays. Over 1 million objects allocated.
Probably string internal use.
Now, here's the thing. One of the things that I really that's kind of ugly. All right, I'm going to try switching over to 14.4 to a bigger resolution. Hopefully, I won't blow up the projector when I do that. All right. Okay. Well, the UI is a little bit bugged here. Okay, so this is actually one of my favorite features of your kit, which is the click a button and find my problem for me. So what this does is it actually walks through the app for you and performs a whole bunch of checks. So it looks for duplicate strings, null fields, sparse arrays, right? And this is actually starting to get to where you can start to find some of the issues. Now, I think this one here doesn't help with that. And that's because this one's a little bit of a nasty one here. Because what actually is going on with this one, and the only way you could find it is go into the char array here, look at the paths or look at the instances themselves. If you look, eventually, so this one here actually, I believe you'd actually have to go into JHat to see, but it's actually a static array. Looping. It's actually looping and adding string values to a static constant. Let's see if we can find instances of this. Actually, let's try this one. I want to try one thing here. Let's try open up the default, the empty one. Compare. So it's doing the same thing here. Is it showing you the delta between not doing anything and what I actually looked at? So the way to actually get this one to eventually is you'd actually have to go look at this what the values were that were in those character arrays, but all the data is there. Okay.
Do you know why it's having such a hard time telling you where that was allocated? Why it's not able to give you? I mean, it seems like that's a pretty simple problem actually. If it's just a static array, like why is the tool so weak?
Well, because it's actually is it doing that?
You have to be profiling the app. It doesn't track the allocation point with the object.
It
You
tracks.
have to actually have a profiler running that is actively tracking that, and then you'd be able to see it.
Yeah. So here is the actual thing that I wrote to actually do this, and it's actually better on this version of the JDK. It doesn't kill you dead. But if we hit this, here, and this one's only set up to use 80 something, so hit its wall. It's going to GC like crazy, and then it'll eventually give up. But this isn't. You could actually see this one just happen as well. Killed the server. Never mind. Okay. Let's see. Ooh, here we go. This is a fun one. Let's look at this thread dump. So that one was pretty brutal actually. Let's see if we can do something a little bit easier. Let's see. Watching me click around in my finders for deciding stuff here. Okay. So this is this one's a little bit tricky, but we'll see if we can go through it here. So this is a thread dump that we got from the IT department. And in this one, you'll see a ton of stuff going on. What are we looking at here? Anybody kind of want guess kind of what we're seeing? What's that? I'm sorry. Oh, I'll make it bigger? Of course. Yeah, sure.
We're guessing it's a deadlock.
It looks fine for me, right?
We see a lot of blocks. We're saying deadlock.
Is that?
How many threads are blocked?
Yeah.
A lot.
Did you simulate this block, or is this a real block?
This is a simulated thing, because
using latches.
Yeah. So here's an interesting thing. What's that? What are all these?
As many connections as possible.
What's it doing?
It's opening dozens and dozens of connections.
Yep. You found the twist.
Uh-oh.
Sorry, I can't.
It's okay.
Yes.
Never mind.
So this is actually what this is actually a server that's misbehaving by opening lots of network connections. So not only is it serving requests, it's also opening network connections to read stuff from other services. And so that's something where you can see this when you look at the thread dump very easily to see what's going on.
You just read the code there.
Must be that open as many connections as possible method.
Yeah, right.
Yep. Now,
See, somehow I have a funny feeling that when my code breaks, it's not going to have a method name.
Awesome to have that kind of tool, right?
You know, be very, very handy if the top of the stack trace was die horribly.
it is, yeah, it is, exactly. And And well, this is part of where like it's really hard if you're just looking at somebody else's code, right? So like originally when Nimrit and I talked about this topic, it was like, oh, this will be totally cool. Let's put these horrible things up. And then it's like you start looking at them and you're like, that would be a totally jerk thing to do because like you're never going to figure out most of this stuff just because it's too hard. I'm going to show you one that I thought was kind of interesting.
How many things would pass, for instance, 5 bugs?
Would pass fine bugs?
Yeah, something like that. How many of these?
A lot. It would catch a lot. You know, it's. I think the thing that was the most surprising to me is I first wrote this crash dummy a year and a half ago, and it was on 1.5, and a ton of this stuff would just kill your machine or your VM deader than a doornail. And on 1.6, most of them don't kill your VM anymore, which I thought was really, really cool, and also made for a slightly harder thing for this because it is kind of fun to hit a button and blow everything up. But yeah,
It's cool, but I'd still like it to scream somehow.
like it's a what?
Probably not.
You want me to do some stuff that's actually going to blow up?
No, I mean it's cool that it survives a lot, but it still would like that not to be quiet because there obviously are problems.
You'd like it to what? I'm sorry.
He wants it to scream out loud.
Not be,
Yeah.
not shut
Oh.
up.
You know, something that does little beep codes out of the front of the computer like they used
Something
to.
like that, yeah.
Yeah.
So, Will, out of curiosity, have you read this in Google's web apps services?
Have I? So, question is have I run this on App Engine to see what happens, aside from getting shut down from my account? I haven't. Most of these, honestly, I mean, Google App Engine actually is pretty tight from what I can tell. I haven't put Crash Dummy on it to see what would happen because I don't want to get angry letters. You know, I want to call them and say I'm going to do this thing. They're going to say why, right? And I'll be like, because the people at SeaJUG were curious.
Because I'm running a new book and I'll feature you in it if you survive.
Exactly. And nah. Okay. Let's see now. Let's reconnect to Tomcat. Okay. I'm going to show you kind of an interesting one here. One of these is this one here. Generates 150,000 threads. So what do you think is going to happen? What? You say small potatoes?
Small potatoes.
What's that?
JVM will crash.
VM will crash. Any other guesses?
It depends on
Depends on
if
your OS.
all the counts are retained in the memory, yes, it will crash.
Well, you could run it at heap size because it couldn't find enough space to allocate all the classes.
Around heap size. Okay.
Thanks.
Depends on how much memory you have allocated.
Yeah.
Okay.
Isn't there a limit on the thread address space?
Sorry, what was that?
So as I recall, there's a limit on the thread address space that you can tweak.
Okay.
No, I ran into this problem.
Okay. What do you think is going to happen to the CPU?
How fast is it?
So this is a 2.4 gigahertz Core 2 Duo. Got 3 gig of RAM, but I've only got like 80 something. So what do you think is going to happen when I hit go on this?
Burn its way through the table onto your lap.
If the spreads are doing nothing,
Yeah, they're not doing anything. It's just like they want stuff.
So actually, this is even more interesting to watch on JVisual VM, because then you'd see what was going on. But the VM doesn't die. It just burns along. It never allocates more than about 600, 700 threads. It just chews its way through the whole thing, just sitting there doing it.
Garbage collection is fun.
Yeah, it's pretty interesting.
This could actually be an example of Doug Lee's, when you run out of, when you don't have any more threads to give out, you run it on the current thread. So it could be that actually it's not really starting any more threads, but it's just passing the thread of control over to the new thread and then waiting.
Yep. Yeah, I mean, and for me, part of the moral of the story is the fact that the JVM is smart enough to not just die horribly and kill your machine, right? It didn't even, like, frankly, beat the CPU to death. You can kind of see it. Let's try it again. And the key to seeing part of what's going on here is sleeping, right? The threads themselves aren't doing that much. So that's part of it. But yeah, it just sits there and hums along. Okay. So we got.
So what were those threads doing?
What was that?
What were the threads doing?
What were the threads doing? Like basically nothing. Just counting, incrementing a counter. That's all.
Something CPU without any wait states?
No, I mean it wasn't like computing pi or anything interesting or doing fractals or. No,
Or
it's just
going into a position where they might all be waiting, tempting the system to launch more.
I think it's actually just waiting for the threads to get reaped. I think is all that's going on.
Okay.
Yeah. You could hit. We could. Yeah, let's do a thread down.
What if we allow the thread to do something, and what kind of behavior we will notice in that case?
Well, it's a great question. So the question is what are these things actually doing? So this will take a little while.
I think you might run out of memory.
Yeah. So it's doing sleep. So I'd have to go double check my implementation. Maybe I'm calling sleep explicitly.
Should just increment along.
Forever. So here's a fun one. So let's see. Okay, so this is the easiest one in the world. I generated a deadlock thread. Okay, so the easy way to find this, if I hit thread dump. So anybody remember like trying to find deadlock threads that being this total nightmare?
Yeah, they're the ones that are titled deadlock thread.
Yeah.
In addition to the fact that in these cases are just named deadlock generator. These are the names of the thread. As a side point, of course, naming all of your threads if you're doing threaded work is a really good idea to help you figure it out. It just dumps it out for you now. So finding deadlock threads is actually not that big of a deal nowadays. So the question, I think, Daniel, you asked about when do you do this? Having IT do this once a day or something like that, if you're doing a threaded app, and just say, is there anything sitting there stuck, is probably a good idea. But what's interesting is you can do this hundreds and hundreds of times and just sit there.
I have a question. Actually, you listed not all of the kind scenes, and the most difficult one, how do you deal with open and not closed streams, open and not closed file handles? Because this is something that is hidden under JVM stuff. So sometimes, if you are going with too many open handles, you cannot figure out who. Either you are using too many trees, or you have too many open streams. So what's the methodology, strategy for such cases?
So the question is how do I deal with open
Open
files?
not closed streams, because you will have to deal with some nasty behavior. For example, for Windows it will work fine, because if you have not opened they are free, there are no references, garbage collection mechanism will be turned on and will clean up. Yes, it's fine, which will not work in case of Unix systems.
Your OS will run now with 5 descriptors.
Yeah.
So well, eventually.
Yes, that's great.
Yeah,
but if you have a lot of
But that's actually not a problem in trying to figure out the problem.
yeah.
But there's a command in Unix to
You
Yeah,
can increase
exactly.
So I mean, at that point, you're working at the OS level, and you really, I mean, you're below the Java VM level, so you have to use OS specific tools to troubleshoot. This is cool, but if you have code base more than 4K, 4, 5, 6K of classes, you will have to, and yes, I know it's a bad thing. For example, somebody requires, gets a resource from URL. Yes, it is found, but hey, who will close it? So such a kind approach is spread through all code and try to dig it. Or sometimes you are passing this stream to somewhere deep down. Try to find it where it should be closed.
So something like Findbox really helps there.
Yeah. So in terms of strategies,
Not all the time.
Not all the time.
like generically speaking, web servers shouldn't be touching the file system like that normally, right? So are you doing a web server application, or are you doing your own like back-end processing server?
Kind of backend process.
Web frameworks will typically open a lot of files. I'm
Well,
part of the Wicked team, and we had a bunch of problems that were very hard to
so you were doing a framework.
track down. Yeah, that was part of the framework.
Yeah, I mean, the other thing is that
We had plenty of problems with JSPs in the past too, in all the versions I remember.
You recompile your JSPs.
For me, I don't know, I'm not sure, but I came to desperate kind of strategy, just using bitrace, proxying the input stream, and catching. If somebody doesn't call close stuff,
Right. So what I would say is more generically, that problem to me would be like a question of I've got a limited resource. So on database connections, how do I deal with that? Well, I have a pool that I use to check everything out from, and so some of the tools, for example, like P6Spy, there's a couple. So P6Spy, every time you execute a piece of SQL, it can generate a stack trace for you. So what you could do is you could have a pooling library, and every time somebody checks out a file reference, then do a stack trace, and then store that stack trace with that file reference, and then when you're done running your app or at whatever point, then whenever something got handed back and actually closed, then you close that reference and you throw that stack trace away. So then you get a list in memory of all the places where you've opened up files. Now, is that something that's realistic to do? It's going to depend a little bit on your app. But anytime you have a resource that's in contention like that, if you said, well, I can't have more than 10,000 files open or whatever, that's kind of the pattern that you could look at. But it does mean that you have awareness of what's going on. If it was an app that you've never seen before, you could theoretically hack the JDK itself, replace the class file. So anytime there's an open and then a close, and then look for those to see what's going on. That's pretty gruesome stuff, though.
Well, and actually don't forget to search for bugs, because the problem that we have turned out to be a JDK bug.
The JDK bug?
Which was not solved for many years.
yes, I can.
But that's pretty nasty.
Could write a what?
An aspect.
Yeah.
That'd be a non-invasive way of sort of, kind of like what you did with proxy and then technicals actually make the API calls.
Yep.
One aspect on JVM code is a little bit more tricky.
You can put it down, or you can drop that in an extension.
Okay. So I'm going to do one last one and then wrap up, because it is 8:30. The wrap up shouldn't take too long. So this last one.
Right. Yeah, I know.
Okay, so this last one I'm only going to do with screenshots. And the reason I'm going to do screenshots is that this was this is an actual real live problem from production that we saw. And I got a 2.5 gigabyte heap dump file. It's like, what's going on here? So that's what I wound up seeing. If you can't see here, half a gig of hash map, half a gig of hash map entry, half a gig of hash map entry. Essentially, the entire thing is hash map entries.
Somebody is too eager.
Somebody's what?
Eager.
Eager?
Yeah.
Describe that. What do you mean by that?
For example, tries to cache a lot of stuff.
Tries to cache a lot of
Yes.
stuff. Okay. Eager. Okay, you're very, very close there, much closer than you'd guess. So this was the next thing was, okay, well, let's see if we can figure out what these are. I had the same problem that we had before with some of this other stuff, which was, okay, I've got a bazillion little itty things, just like that class, that character array. Okay, now this was using the ORCID tool to figure out the waste. A little bit closer here. 9,000 entries for the string name, display name. Okay, now what the heck? Where's that coming from? Where's that? Now those are ones that wouldn't necessarily mean anything to you guys. But they came from the app itself. So now I looked for null fields. 2.9 million hash map entries. Well, what's the next thing on here? Hibernate.org.hibernate collection persistent set.
Is this a database snapshot?
Huh?
Is this a database snapshot?
Basically, yeah. Somebody written a query. The query actually came back really fast from the database, but it was practically like, just give me everything in the world. And so what was going on and why it was blowing up was it was loading all the objects in, and where are all the hash sets coming from? Anybody, any guesses?
It's not proper association. Association unstable, which contains too many records, and not proper association described in Hibernate for it.
Actually, no. Hibernate, everything, all that was fine, right? You'll notice that they're nulls, right? What these were is these were all the hash sets for all the associations for the objects that were getting loaded, right? So let's say I load in, let's say I have a table and it's got a collection on it. Let's say it's a country table and it's got a collection that points to states, and I'm loading in. Just bear with me, it's a bad example, whatever. And I'm loading in a whole bunch of countries, right? Well, Hibernate's also putting in empty collections for me for all the states, even though I haven't fetched those. That's what these all were.
Yes, but it could be a different problem. For example, cross stuff.
Oh, yeah. Well, the actual problem at the end of the day was a bad query, right? It's just that it wasn't showing up in the database as a problem. It was showing up in the app server as a problem. Without memory.
So maybe it's interesting to show how you narrow down to the actual query or method where it's used.
That is an excellent one. Which is a good segue into the last bit of slideware. So I'm going to talk about that. How do you find that? So the question was the unique horrible things, and so it was funny because you actually mentioned, well, we found a JVM bug, right? Well, finding a JVM bug is a bit like getting, having somebody break into your house and steal your stuff, right? Does it happen once in a while? Yes. And it's very much of the 6 o'clock news story, right? Oh my God, I found a bug in the JVM. Yeah, kind of thing, right? And
what's worse is seeing that same bug sitting there for 4 years.
Yeah.
That's worse.
Yeah. So you try
Not
emailing.
4 years, try 10 years.
Yeah. Well, my bug, of course,
And
I was
it's not a
especially
bug, it's
bitter
a
about this
feature.
when I was at Apple was, same day release of the JDK for the Mac, right? And that bug has been sitting open since '95, right? So, yeah, same thing with the driver bugs, right? So, if you're using anything but SQL Server, then the vendor drivers are actually pretty good nowadays. Like Connector J is actually freaking awesome. Actually, it turns out it does all this caching stuff for you and all sorts of neat things I didn't even know drivers were doing nowadays. But if you're using SQL Server, then there's another set of drivers that you can buy. And so the thing is that most of this stuff doesn't actually come up for people under normal circumstances, especially if you're building web apps, right? It's like I go into work every day. What am I doing? I'm writing a little web app that's putting a front end on a little database kind of stuff. Okay, you shouldn't be running. You shouldn't see this kind of stuff. This is not going to be what's going to be killing you, unless you're doing stuff like you're writing your own threading code or you're doing something really, really wacky. And even there, most of the scenarios that I've come across that people are talking about writing their own threading code, they probably actually could just use an in-memory object database or an in-memory database, and they get all the things that they want when it comes to dealing with objects. I get full ACID, I get all that stuff really fast in this persistent store, and I get out of the business of writing threading code. So just because you can, because it may be sexy and fun, don't do it unless you really need to, or I want to write my own server, I want to write my own framework kind of stuff. But if you're doing that, make sure you know what you're doing. Stateless parallel operations. Basically, keep it really simple when you're doing stuff. Sessions is an example of a place that can be brutal. Let's see, we talked about all this stuff. Most normal apps. So this was the question earlier about, well, how did you figure out what the query was that was bad? That actually is pretty straightforward using a tool called P6Spy. You guys mentioned another one. What was it called? JVDC. What was it? Driver Spy? So P6Spy is a driver shim. It sits between your app and the real driver, and it passes through all the queries. And then you can configure it to do all sorts of things, like only look at certain kinds of queries, or what we usually do is we just say, log every query that came rolling through here. And you can flip on some really cool options, one of my favorite being generate a stack trace for every single SQL statement that comes through. So what that means is basically you know exactly where all the offenders are coming from. It doesn't matter if it's coming from some wacky aspect that somebody defined or whatever. As long as it's going through that driver shim, you'll see it. We actually found a couple of interesting ones there where the MySQL driver, the Connector J driver, was actually optimizing out traffic going to the database. So we had queries that were never hitting the database because the driver was saying you don't need to go to the database to get that. And what was interesting was that we were still having performance issues in the app server itself because we were still doing so much pointless traffic.
Question. JDBC drivers shim, is it free?
Yeah, this is free. P6Spy is free. Yeah. And what the log files that it produces, you can pop open in Excel and check a look at. Or there's these tools called IronTrack and IronEye SQL, and you can download those from this link here, which let you open them up. And those are free tools that let you see graphs and timing values and stuff like that.
Actually, what's interesting, maybe, I don't know, from database standpoint, Microsoft has a lot of tools. Their performance monitor, SQL profiling is very good. Does Oracle have or has such tools? Does anybody know?
Yeah, it's pretty good. Tools to over to swing plan.
Are they free?
Well,
Well, though technically MySQL is Oracle too.
From my experience, I mean, I worked with MySQL, Postgres, and in the past, and I've never really had too many issues. Of course, I'm not a DBA, but just being able to take queries and analyze them and see where optimizing and stuff like that, it's not that hard to do.
Yeah.
The tools are pretty good across the board.
Yeah, like if you find a piece of SQL and it's taking time or whatever, usually the tools for the database figure out what's going on pretty good.
Or something more extraordinary like DB2.
I'm sorry?
Like DB2 stuff.
I've never played DB2, so.
So part of the point of this comment here is I know that there are people, probably even in this room, who are working on systems that have really insane performance requirements that they have to hit. If you're doing a web app and you're doing something like, well, there's 50 people that need to use it in the accounting department, I mean, you just got to be paying and kind of bring some reality to what's going on about what you're trying to build. And so stuff if this is what you're doing, you're just building a web app and you're talking a database, that's your thing, this is actually all you're probably going to really need. 99% of your problems. Just track right back to that. Let's see. A couple of tips to help you dealing with stuff. Single user on your dev box is a good starting point. Start with starved resources. So most people have big fat servers running in production, right? Well, but the thing is the big fat server running in production is getting sliced up really finely with all the people that are using it. So basically work on your dev environment and even kind of artificially constrain your resources to help find the issues that are going to pop up. So like, don't set your memory value to huge on your local dev box and then think everything's all groovy. Keep it tight, keep it lean. You should still be super fast, because if you're not, then that means you know you're going to have problems. If you're sitting there with like one user under just hitting a page and you've got a perf issue, don't even bother sending that into production. Let's see.
Well, production boxes are always way faster.
Production boxes are
Always faster.
No.
Yeah, exactly.
No.
So, which actually is the next point about a baseline and a scorecard. So, when is performance fast enough? When is your, don't fail, like if you've got out of memory problems or what have you, but then you get into sort of more abstract, like performance issues and threading and stuff like that. Know what your baseline is and go with that. Database tools we just talked about. Future, okay, where's all this going in the future to deal with this stuff? The biggest one I think is stateless services. Don't have user sessions, and just because the servlet spec gives you a session and you can start throwing objects in there, just don't even go there. If you can get away from that, that's going to be a really good thing. I'm going to give you an example of a shopping cart. Okay, so there's a local company that I do a ridiculous amount of business with downtown, right? And I currently get my books, my groceries, like all this crazy stuff from these guys. And they have a shopping cart that I now have something like 500 items in. So I'll mark and save for later. They hang on to my shopping cart forever, right? So obviously, Amazon's using that as another data point for me to track what's going on. So the shopping cart is actually not a session data value at that point, right? It's just a permanent, it goes on my permanent record. so kind of the point is that like there's really not actually that much stuff that you ever really have a good use scenario for using the servlet session. Now that doesn't mean that we don't have apps that we haven't written and everything else that use it, but certainly for the future, if you can get away from not having to do that, well, why is that cool? Okay, well, all of a sudden I can start scaling out by adding more servers, and I don't have to worry about session replication between those anymore, right? So what's the one thing that's left? If I have, one to n app servers, what's their contention point? The database. That's the next point here. So there are a lot of really cool things going on right now with key value data stores. So it's a lot of stuff is inspired by Google's Bigtable. You can get MongoDB, which is a nice implementation to play around with of what that looks like, because the first time you go in and you start looking at what non-relational data stores look like, your head's going to go psh. Amazon S3 is another example of that. The thing about these is that, like, just getting your head wrapped around and started with this can be a lot of work. I think the easiest way to get started, and this would be like another future talk, to talk about Google App Engine gives you a nice implementation backed by their Bigtable implementation of a key value data store that you can play around with, and you can literally be up and running with it in 10 minutes, and it's free if you have less than 5 million hits a month, right? That's the way that you get out of having your data stored to your bottleneck. It's a different set of design patterns, but that's where you eventually can go and scale. If you really care, you can start tracking CPU and memory usage for page view. App Engine does that. Every page view, they send you back in the headers your CPU and your memory allocation. And no CPU, I think memory. And then the last one is response time and browser rendering. My favorite performance bug of all time was this. Working on this with this company, and they were just really pissed because the site was awful slow. And when they looked at it, they were like, the page takes forever to come back from the server. So, the initial thing was, well, let's look at the page response time from the server, beat it to death, optimize it, tune it. The page was coming back in 10, 50, 100 millisecond. It was freaking awesome, right? We got all tiled in. Page is still slow as hell. What's going on? Any guesses?
Multiple requests, 2 connections, and latencies.
Nope. Good guess. Nope. Really, really crappy, malformed HTML. The browser was taking 20 seconds to render the page. And you'd see the client browser CPU spike to the top. So the page was coming back instantly. And it was just the thing that was taking too long to render. Pay it and watch what's going on. Finally, last little point here. You don't want to find all these things in production, right? We've been looking at these heap dumps and using these tools, and it kind of works and kind of cool and kind of a pain in the arse, especially if you've got something like lots of strings and you're scrolling through or whatever. A lot of these might take you hours to fix. Don't do that. Don't do that with production. Get it into your environment with good automated tests, good practices, and a good perf environment. Getting as close to production as you can. If you can't afford to automate your test suite, then you probably are having also trouble affording to ship, because you're going to have that long, brutal release cycle, which is my last shameless plug. So I'm doing a class on agile testing, continuous integration test-driven development, JUnit. Everybody here knows what ham-crest assertions are in JUnit, what theories are. There's a ton of great features in JUnit that many of you guys probably haven't heard of. Talking about how to test databases in the web, and documentation generation, and all that good stuff. And there's flyers for that in the back table. If you guys want to talk about that.
Why you don't talk about TestMG?
Why don't I talk about what? TestMG? Just another tool. I mean, if I was getting to the point where I'm getting people talking about that means they're starting to pay attention. What about behavior-driven development, right? Same kind of thing. It's where are you pushing, right? If you're at the point where you're really actively using all that stuff, and your company's adopted it, and everybody in the company's doing it, but this will help get you to that, where you're starting to have those conversations. Okay, that's it.
Thank you.
Thank you, Will.